Hi, this is Shaman of Noasic, creator of airhdl, and today I will show you how you can use airhdl to create register file for integrating into a ZYNQ system. So what I have here is the base ZYNQ system that comes with Vivado, and I'm going to create a simple register file with just two registers and integrate it into that block diagram here. So to get started, let's fire up the web browser, and this is airhdl, and I will create a new register map and call it myregs, for instance. I could add a description here, my register map. This is just for documentation purposes. And I need to create or to provide a base address here. So for that I will, I could just make something up here, but I will look into the Vivado address editor, and I will copy one of the addresses and paste it here. As you see, there is inline validation here. So I will make this a 1 and remove this, and we're good to go. So this is the register map that I just created, and if I'd like to change anything like the base address or the name, I can just go to edit register map here, and then I could change whatever I want. So this register map is empty for now, and I will, as I said, I will create a control register and just call it control at address offset 0 from the base address, and this is a read-write register, which means it can be read and written from the CPU. And let's go create this register, and I will create a second register which I will call status at address offset 4. And this will be a read-only register, so it will only be read from the CPU, and the value will be provided by the user logic. So here we have our two registers. I can see here the access mode, so the first one is read-write and the second one is read-only. And as with anything in airhdl, if you change your mind, you can just edit and make it, for instance, a write-only register, and that's just a few clicks. But I will use read-only for now. So now let's go into that control register. It's empty for now. So I will I will add a field and just call this field LED. So let's say I want to connect the output of that register to LEDs. So I will create an LED field which starts at bit offset 0 and has a width of 4 bits. I can provide a reset value here, and yeah, create that field. And there it is. The first lower 4 bits of the control register are now assigned to this LED field. And same for status register. I will add a field and call it, let's say for instance, button. So if this is something that I want to connect to push buttons, for instance, and let's say I have 2 of them, this is how you create the button field. So now let's go back to the register map. What I can do now is run design rule checks if I like, just to check that there are no collisions between the registers or no name conflicts, stuff like that. What you're seeing here is the revision number. So this is a number that gets incremented every time you change anything in the register map. So if you change the name of a field or address of something, or even just the access mode, as I did earlier, the revision ID will get incremented. And this is very useful to check that generated files, for instance a C header and VHDL component, are from the same revision of the register map. So now I'm done with the register map entry, and I can go ahead and download files. So I can download the C header. I'm not going to use it now, but I can just download it to show it to you. I will need the VHDL package and the VHDL component for the Vivado design. And let's have a look at these files. They're here. So the C header is it's in another window. So the C header is here. You can see that you have the revision number that we just discussed. There is and then there are defines for all the constants that you would care about in your software. So for instance, the base address of the register file, you have the offsets of every register, and for every register field you have the bit offset at which the field starts within the register. You have the width, you have a bit mask if you need to clear the field or set all the bits of the field, and you have the reset value. So this is the C header. What we have next is the VHDL component. So with the AXI4 interface and then the user ports that connect to the user logic. And we have a VHDL package which is similar in content to the C header. So you have all the register and field definitions. So now we need to integrate that into our Vivado design. And this is quite easy actually. So I just need to add the sources here. So add files, and I will need to add both the component and the package, and I could copy them into the project because they are somewhere else right now, and finish. So yeah, it's here, it's imported, it's updating something. And then I will go to the block diagram and add a module. And the regs is the only one which shows up here, so I will use that one. And there it is. Here it is here. And there is a designer assistance available, so I will just use that to connect the AXI4 bus of the register file. So that's done right now. And let's see if I can zoom a little bit. Yeah, so you can see that Vivado automatically connected the AXI4 bus and the clock and the reset. And what you also see on this component are the ports that correspond to the register fields. So if you remember, we had a status register which has a button field which was 2 bits. So this connects to this register field. And we had a control register with a LED field which was 4 bits in width. So this is it. And then there are strobe signals here that can be used to detect read or write accesses to these fields. So if your user logic needs to know that a field has been read, for instance, then you would use this signal. I'm not going to use it right now. I'm just going to connect the status register to an external port, and same for the LED. Make external, and you see that Vivado has created the corresponding ports. And now I can zoom out again, and that's it. That's how easy it is to create a new AXI4 register bank in airhdl and integrate it into Vivado block diagram. Thanks for watching, and check out airhdl.com if that sounds interesting to you.